open share, open. Yes. First of all, I upload the Sentinel 2
Yeah,
image
signal to.
and make a filter and make a median and select band 1, band 2, band 3, band 4, and clip ROI.
Yeah.
After this, then I print a composite image. I will get, I think, 64 image.
No, in this time when you put the median, then it show only for the one median composite image.
Ah, yes. Okay, yes. After this,
Yeah.
I I will visualize
Yes.
function
Yes.
and add layer.
This
Yes.
is your imagery.
This NDVI not necessary layer.
Yeah. No problem.
I I make this just for example. Yes.
Yes. So this type of
I will
index.
make all
Yeah.
indices and calculate this and add to the image,
Yeah.
composite image.
Yes.
After this,
Yes. Yeah. So
yes,
now here you can see variable info. Take the some class value. So here you can see. So first water. What is the value you can put? You can see. You put the 1.
yes,
So water is the 1.
yes,
And then you can see the 2, 3, 4, 5. Total 5 class.
fine,
Okay. So
yes,
just so you can put at the 1, 2, 3, 4, 5. And also put their
5
name.
plus,
Water, barrel
yes,
land, vegetation, forest,
yes,
and build
yes,
up.
I understood.
We put at that. And also put their color plated. Okay, color plated.
Yes,
And which type of band we extract from here, suppose B1. So this type of band we need, and also we had some external band, suppose NDVI band, NWI band. So this type of band we already created in here, and just we simply put here this all of band, because this type of band we further use to get the information from our training sample.
yes,
Okay, and then feature same,
okay,
just we simply merge all of training sample. We take all of this training sample and merge, and further we are just simply make the 80% data test and train, simply separate. And further we are just simply extract the sample from our sample region function, and further we just export the
Sam,
sample.
how we can to split samples?
Okay, so in this time we take it, suppose here
How
you
we
can see
can
the
do this?
80%, basically 08 is the 80% and 20%.
Yes,
Okay,
it
80% and
it
20%.
mean
Yeah.
60 percentage.
Yes, less than equal
Yeah.
random 0.8 and greater than random 0.8. So it takes the 20% data for testing and 80% data for training.
Yes.
And further we are just simply export this sample file. We need the sample and class values. Basically sample, you can see sample mainly stored the lot of things, samples, all of sample, basically water, it's our sample, barren land, build up, all of the value also extract from here. So now we let's check what happened. So it's done. One. Just I try to open file. Just drive. Here you can see my file.
Your drive.
Is it samples
Hold
carbon?
up.
Yes, yeah. I get it.
Mm-hmm.
Yeah.
Yeah.
This is the file. So this file you can see, this file mainly stored all of information. Basically all of
Yes,
samples
I see
information.
it. Yes,
I can
I
see
see it.
B1, B2, B3. So first, then also get the class value, also sample, train and test. Okay, basically 80%
Yes.
data we use at the train, and 20% error for a test. All of you will get from here.
Yes.
So now after you can see this is our imagery. So now further you simply go to our code editor and import this package, and then just simply connecting our Google Drive. So just I click on here again, and now connect with my Google Drive. This drive is already stored. These two files. One is that CSV, another is the raster file. So I use this image here, and also continue. Then further click on here the continue. Connecting my Google Drive.
Sir, I want to prove the CNN. It is better than random forest.
Yes,
But
CNN is more better. CNN is more better.
Yes, but I get the accuracy from random forest about 97.
Okay, we check here from what the accuracy can get from here. Then we try to. Suppose in this
It
time
is
class
very,
number.
very high. How I can compare with the CNN
Okay, let me
results?
check from, and I simply go to my drive. My drive. From here, I just try to find out the folder, which that is the DL, and from the DL, I just simply the file which is the Carvala CSV path, and further I simply at this. And also Carvala Sentinel copy the path simply test here. So now we try to run the code. Now it's also okay, there is no problem. Input the two things. So now we are just load the imagery. Loaded. Okay.
Yes.
You can see this is our imagery. We can get this type of image. So this is our imagery. It shows the two color composite. If you want, you can change it the band combination. You can see the red, green, and blue. Mainly 4, 3, 2. You can easily change it the combination also for the other visualization. So we are using here 4, 3, 2. So this type of imagery. And then further we are just simply read the sample, all of sample which I extract from here. On the code, now we can get all of samples from here, B1, B2, B4. So all of the sample, also class value, also their sample.
Yeah.
Okay, all of them will get from here. And further, just simply spilled, we train and test things. We separate these things. Only 80% data we just apply the CNN model, and 20% data we try to check about the validation or accuracy about that. Now it also okay. We can see train feature how much, test feature how much, train level how much, test level how much. We can get all of information here for our model.
Sir, can you record this lecture?
Yeah, it's recorded. So then further we just make the model using our train image. Okay. So for that you can see make model for your data input shape. Just I simply run and neuron. So it's very important for that for accuracy about that CNN. How much neuron we want to put in here. So in this time we can get this type of neuron here. You can see. So neuron, drop, kernel, pool. So basically this type of parameter. Okay. So this parameter is not fixed. Okay. Change it for the different way, different types. We have to change it. This type of value. Suppose neuron value, drop value, kernel value. So these type of things we take. So first we'll try to run the code and check what happened. Will be
so it is okay for my project this parameter.
Yeah, no problem. We check the accuracy. Then further, if you get the low accuracy, then we'll also try to change this type of. and try to get the better accuracy about that. You can say activation is the ReLU. We can get this type of parameters such as I can say sequential model where we here can get this type of okay no problem. And now we train the model. Okay, in this time we are using the Adam optimizer. Just click to the run and then that accuracy fix.
What is Adam?
It's one kind of optimizer. So basically CNN, this model, we can get different types of optimizer. Suppose Adam is one kind of optimizer. So we can in this time this
Yes.
model we just compile with that Adam. And further you can see we just feed this model mainly X train and Y train, mainly train input and train output. And further here you can see the batch size. The batch size is 1024. So okay, no problem. Epoch is 100, no problem. So now you can see in 100 time feed this CNN. Mainly you can see the suppose there is some basic things about the CNN. So CNN, suppose I put the CNN algorithm. So CNN we can get some this type of layer. Suppose we can get the input layer. Suppose okay, just I try to open CNN we can get that input layer and hidden layer and output layer. So here you can see suppose it's one kind of suppose land use land cover class. Suppose it can be vegetation. Okay? Pixel of the image red feed as the input. Suppose it's my input 1 pixel of vegetation. I simply input it's my input level. So it will be input level and then further it creates a lot of hidden layer. Here you can see get this type of hidden layer. And hidden layer it's basically depend on your model. If you are have lot of class, suppose vegetation, then forest, then also cropland, so you want to make the lot of classes, then this hidden layer is also increased. Okay, in this time you can see we can get the
Yes.
total 3 hidden layer. So in this time there
Yes.
get the output total, you can see the output we can get from here. So dog, bird, cat, the output layer. So basically, this is the common
Yes.
structure about that. So input layer basically we put this type of pixel, our pixel value. Suppose vegetation, cropland, all of pixel value we input in here. Further, it create this type of hidden layer, and then from this hidden layer, it make the class. Suppose dog, bird, cat, or vegetation, cropland, build up area. So for this hidden layer, when you calculate, then we have the different types of optimizer. Okay, suppose Adam is one kind of optimizer. This type of things also put in here, and so you can see the result. You can see here. You can see for is epoch. You can see the epoch 0.19, accuracy 0.93, 0.93, 0.93, value loss 0.18, value accuracy 0.93. So it check each time. Basically, total 100 time it check individually using that your train input and train output. Okay, and check what the accuracy we can get for each time. Total 100 time it's check about that. So now
So
these things
when I increase epoch, it is the accuracy it is increased or what?
in this time it check
When
the
I
is hidden layer accuracy. Suppose is hidden layer accuracy. Suppose I put the total 100 epoch. So in this time it take the 100 time. Suppose 100 time check the accuracy about that for our imagery. Suppose you can see the 11 by 11 epoch we can get the loss 0.1 accuracy you can get 0.93. So it check for individual accuracy it check. Suppose I have a model. This model I want to input the total 100 time train. I train this model 100 times, and each time I
when I
get the
when I put
yeah
when I put 105 15,
yeah.
what's
Then it yeah then it
the
epoch.
result?
Suppose I 150 I put in here. So now it take
Yes.
the accuracy 150 times. Okay? 150 then two.
Yes.
So all of this will be check in here. You can see
What
that.
about the result? What about the result of accuracy?
Yeah. In this time you can get this type of accuracy look like that 0.8, 0.89, 0.91, sometimes 0.93, 0.935, also 0.93.
Yes.
It look this type of accuracy. When I put the epoch is 100. And these things we are also show as a histogram. So these things can just show as a histogram. The train and train loss. We can,
But epoch not 150,
yeah.
just 70.
Suppose we just
It
put
is
at the,
okay.
yeah, no problem.
Uh,
Suppose I put at the 70 and what happened that we can see. So now 92, 94, 95.
my English is not better.
No problem. Okay, so basically, it's one kind of neural network. So basically, a neural network is a supervised machine learning algorithm. You can train your neural network to solve classification and regression problem. And basically, epoch is means the training the neural network with all training data for one cycle. In an epoch, we use all the data exactly once and forward the pass, backward pass together, and counter as one pass. So it's one kind of epoch is made up one or more bases, and where we use a part of the data set to train the neural network. So basically, it's train the neural network and then work with that. Suppose when
Yes.
you put at the base size 100, suppose you put at the suppose 1000. Okay, suppose then base size you can see here we put at the base size 1024. Okay, so now suppose I put at the base size is that suppose 1000, 1000, and further I put at that suppose epoch. I put the epoch for 10 times. I put at the 10. Then what happened? So then this 10 divided by 1000. Okay, 10 divided by 1000. Then we can get the
Uh,
is 100. Okay, 100. Base size equal to
yes.
100. When I put at the 10. Suppose these things
Yes.
10 100 times. Suppose because you can see 1000 1000 divided by 10. So each time we can get the
Yes.
100. We can get the 100. Then our base size will be 100. Okay, iteration per
Yes.
epoch 100. If the base size is 100, we can complete an epoch with a single iteration. Okay, so that's why in this time for this in this time we are using the 1024 and suppose 100. Then what happened? Then it will just 1024 divided by 100. Create the you can see 10 point something.
10 points.
Okay, so it creates the
Yes.
total 10 epoch. 10 epoch,
Yes.
mainly 10 base size. Total create the 10.
Uh,
So I multiply.
this it mean
Suppose you can
it
see
mean
the
10 epoch.
uh, suppose you can say run
Uh,
the code and then check that we can get the total 10 result. Suppose 10, you can see 1, calculate, then 2, 3,
yes.
like this 10. Suppose 5, 7, 8, 9, 10, 11. Look. And let's check about the validity. So now further you can see it just show the RAM. In this time we can get this type of accuracy here you can see. Wow, we can get the train loss, test accuracy, and test loss. So train
Yes.
accuracy, so train accuracy you can see, and this is our test accuracy. One line, this is the test accuracy, this is the train accuracy and get in here, and also get about that you can see 10 loss and test loss accuracy about. So now further in this time we are just create the confusion matrix table and then print the our result or the accuracy finally model or using confusion matrix table it created we can get this table. Here we can get accuracy. F1 is for 88% accuracy.
But I
And another thing
uh,
is that okay,
when I
so yeah, so you can get the more better
when
accuracy in the random forest. Yes,
yes,
yes. This is the main thing is that when you want to apply the deep learning, then we need to
concept
increase the training sample. Okay, suppose
in
machine
concept.
learning is work well when you want to apply that training sample 30, 50, 40, it's work very well. You can get the very better accuracy. But when you want to apply the deep learning or CNN, then this type of training sample you need to also increase. So basically, this is the
What
basic
what?
difference.
How can you repeat this?
Okay, so machine learning is work well
Yeah.
for the small training sample. Suppose you can get the water 30, Maryland 30, vegetation 30, forest 30, build up 30. So it's work well
Yes.
when you want to put the small size of training sample. Machine learning,
Uh,
random forest is work very well. But when to apply the
yes.
deep learning, then this training sample you also need to increase. Suppose more than 100. Okay.
يعني
Suppose
when I increase the samples in
yeah,
machine learning,
yeah.
I will get less accuracy.
Yes, but you can get the better accuracy in the deep learning. Okay,
Uh,
basically deep
yes,
learning. When you can see, I show you that
yes,
the difference between that machine learning, learning. Suppose difference.
yes. I understood, sir. So how we can to increase the accuracy in CNN?
Okay, so for that you need to import the more training sample. Suppose in this time, we can take the training sample from here for 30. So you just increase the water training sample more than 100 or 150. Okay,
50, 150.
yeah, you can take.
Uh,
Okay, suppose you can just increase the training sample of each classes, further export
yeah.
this CSV file from here and then import in your and then try to run this model, then I hope we can also get the more better accuracy because it also increase our training sample. Other
يعني
anything?
يعني ان CNN will increase
Yes,
the
yes,
the accuracy.
yes. CNN is a picture the predictive model here. Band index 40 out of range 14. Problem is that band index. Okay, can you hear me? Hello. Okay, can you hear me? Hello.
Yes,
Hello.
sir. Yes, yes,
Okay.
yes.
Let me show
Hello,
you.
yes.
I think some networking issue.
I hear you.
Okay. Okay. Now can see my screen.
No. Yes. Should 13, not 14.
Yes. So now round up.
No, no. Reshape again. Reshape. And fourth, yes. Because my feature is 13.
Okay. So now it's predicate this classification. Further, it also should that. Okay.
Sir, يعني when I increase the samples in Google Earth Engine, I will the result of accuracy is low.
Yes. In Google Earth Engine, you can get the low because machine learning work for the lower sample get the better accuracy, but deep learning we need that more sample to get the better accuracy.
Yes, يعني at the same time I will increase the accuracy in CNN
Yeah.
at the same time.
Okay, so for that, you can also try to increase that training sample on Google Earth Engine with the random forest, then check what accuracy you can get. Then if you will low the accuracy, then you also try to increase the accuracy in the Google Earth Engine platform also.
Yes, I will increase it. But when I do the in Colab, the result of image is not clear or not contain all palettes.
It's not a problem. You can just simply take click on the Google Earth Engine and you can take the training sample just from here. Suppose just simply take the water and then more increase all water training sample. And it also better if you want to use the point without the polygon. If you take some point about the water body, you can also get
Yes, I
the
not
more
about
point.
not talk about this.
And the
I
important. So here I can
I
see just simply take the training sample. Suppose just click on and further we are just extracting this training sample. In the machine learning is work well for the low sample, but deep learning is not working.
sir, I take polygon rectangular, not this shape. It is okay or different?
It's no problem. You can if you want to also take the polygon or point, no problem. But point is more better than polygon.
Point more better.
Yeah. Because in
Uh,
instance we can get a lot of point and each point extract the pixel value. Suppose you can see here
yes.
all point extract the pixel value from this satellite imagery.
Mm. What about my project, PhD project? It is okay or what?
This one.
PhD project. Do you see it?
This
I send you Word file.
Oh, yeah, yeah. Let me. I not check it yet. Okay, I will check it and I'll let you.
Yes. The system diagram is contain Sentinel-1 and Sentinel-2 image.
Okay, great.
Do you open it or what? Or
You can get this type of thing. Total 5 class. 1, 2, 4. It shows a very less amount of build up. Further, save it as zip format.
but they're not urban feature appear in
This is the problem. But when you want to increase the training sample more for the urban or also water body, then it also
yeah.
appear. And we also get the more better result.
Uh-huh.
So initially try to increase this training sample. Okay. So first of all,
Yeah.
we check the accuracy in our CNN model. Okay. Then
Yes.
check the accuracy, and after that we try to increase the accuracy in Google Earth Engine platform. So in this time, if you take the training samples, that was more than 150 for each classes. Take the training sample, look like that. Just take a point. Okay. And further, extract the information from the task tab. Just click on here and extract your sample. Okay. And further import it here, and then check the accuracy. What we can get the accuracy about that. In this case,
Sir,
show there is no urban because it's
no
very
icon,
less
yes.
sample of urban. Yeah.
The sample is يعني should equal number يعني 30 or 50 or no problem.
No problem. Even increasing, no problem. No problem.
Sir, the accuracy of CNN, how can I read it?
You can get
From
the
where?
accuracy.
From
Yeah,
where?
you can see. Yeah, you can see the result. You can see here. This is accuracy about
Yeah.
that. So
This
this
is
is
accuracy.
accuracy.
Yes. Where is Kaba?
It comes from here. You can see. After you can see, after create the model, we can after create the model, we predict our test input. Test input mainly our image, and further we create the confusion matrix table about that level and prediction, and then we print this classification report and put the level and prediction. As you can see, each class it also show about that result. Here you can see about the precision. Okay, so precision, recall, F1 score support. Here you can see for the build up, it show very low value. You can see 58 only for the 58. Okay, very low about the F1 score. So that's why inside in our map it shows there is no red color about that your urban feature. Okay?
Yes.
That's why in this time we try to increase this training sample. Very small. You can see one is red color pixel in here. Very small.
Yes, I see it. Yes.
But when you want to increase this thing, then I hope it also better. We can get that all of things is the high value, the high accuracy. So put the better accuracy about. As well as also you can see about this column. Look like the here you can see.
Kaba. Where is Kaba?
This one.
Kaba.
Understand.
In Google Earth Engine, I have accuracy and Kaba. And this is
Okay. Kappa accuracy about that. You can see accuracy about that 97%. The Kappa is 95% about that.
Yes.
In this time, I think they are not at the Kappa accuracy. They are only at that overall accuracy. But Kappa is also they show about that this is the F1 square. These classes.
Yeah, يعني I where I compare the accuracy with accuracy here, and I will compare kappa accuracy with what?
Okay, so for the kappa, you can just simply check about that your this macro average.
This is kappa?
No, it's not. It's the macro average and weighted average. I think the instant this code is not calculate the kappa. The kappa. Let's show
Cannot.
let me see. I want to show you this. Let me try to add the kappa.
Sorry, I do not understand you.
Okay, I try to add the new code about that for kappa.
Okay. This is idea. It is good for research paper in Scopus or
yes.
Okay. Sir, I hope to visit Iraq. Do you want?
Not yet.
Why?
So basically, now I want to study. I get the knowledge about that. So for kappa square, we just try to write the code. So I take a variable square. Function. Then when kappa square. Kappa square label and prediction and when the capacitor, you can see this library is not imported. So this library will be imported first time reality group. So this get it from scalar. So just simply import the library. But this calculating the kappa, we are just importing this library. This library called the scalar matrix. So from scalar matrix, and you can see there are a lot of things. You can see automatically show about the code. Scalar matrix import go ahead and kappa scalar. Okay, just basically the tab, it will work. You can see the code look like. So now let's try to run the code.
Sorry, what you press? Press just
Tab
button. Okay.
Yeah. Suppose I write the some code, automatically it show the what is the line for that. Automatically predict. So just press the tab, automatically show the result. Just simply import the scalar matrix, import from Cohen kappa square. Now for this function I can easily use in my code. Here you can see there is it. And you can see I just simply put that, take a variable. Now print the kappa square amount. Now run the code again. You can get the 80% kappa square. You can see the Cohen kappa square 80%. And it should about that overall accuracy, you can get the 88%. The overall accuracy. We can get the kappa square 80%. And we can get overall accuracy 88% about that. But you can see when you want to show the random forest, you can get that better accuracy because it's a machine learning. But deep learning, you can get this kind of low accuracy because in the deep learning, you have to put the more sample. We have to put the more input sample. Then I hope we have to get the better accuracy. So I have to send you this code link. You also try just increase the training sample and then check what happened. Then let you know that.
So why the orphan is 33?
Which one?
Why Orban is 33 supporters, and the waters 1043. Yes, here.
This one.
At last line, support.
Support. Yeah. So basically,
Last column.
Yeah, understand. So you understand how was pixel? Okay, it's a pixel number. Okay. So 1043,
Yes.
482,
This is
231.
pixel number.
So yeah, pixel number. So how it we can get only for the pixel number about that. So everyone is recall, precision. So it have different meaning about that. Precision. Call everyone is for basically it's a different meaning about that, and also support mainly how was sample or how was pixel number.
Yes, I understand. After accuracy, macro average. What is macro average? It is
Okay, I think it's one kind of average accuracy. Suppose all of precision, it calculates the average. Then we can get about that. So one kind of, so you can simply start the Google, then you can put better results. Suppose you can simply start there. What is that? Meaning. Quality coordination.
I know.
Precision in suppose get the result about that. You can see. Precision is one of the indicator of a machine learning model apart from the quality of a positive prediction made by the model. It's one kind of quality of positive prediction, the precision. Suppose I put at that because deep learning. So recall, you can see what is the recall. Recall is a metric that measures how open a machine learning model correctly identifies the